Good morning, students. Today we will discuss about the 8086 microprocessor. That is, we will start with the introduction of Intel 8086 microprocessor. So, like as we have discussed in the first class also about the Intel 85 microprocessor, we will start with the little bit structure of the Intel 8086 microprocessor. So the Intel 8086 microprocessor is a 16-bit HMOS microprocessor which is developed in 1978. It is available in 40-pin IC package and it operates at plus 5 volt power supply. So you can clearly see the difference between 8085 and 8086. So Intel 8086 electronic circuitry consists of 29,000 transistors and it is available in three versions, namely 8086, 8086-2 and 8086-1. The clock frequencies are 5 MHz for 8086, 8 MHz for 8086-2 and 10 MHz for 8086-1. So the 8086 has 16-bit data bus and 20-bit address bus. And as you know, the total memory allocations will be 2 to the power 20, that is 1 MB. So the address bus operates in time multiplexed mode. The 16-bit lower order address lines carry 16 lower order address bits at a certain time and thereafter they carry 16-bit data. And the 4-bit higher order address lines are also time multiplexed lines. They carry 4-bit higher order address bits and thereafter certain status signals. For example, from S3 to S6. So what we have learned that compared to Intel 8085, Intel 8086 have higher execution speed, larger memory size and greater number of time multiplexed pins. Another feature of Intel 8086 microprocessor is the presence of 6-byte instruction queue in which the instructions fetched from memory are placed before they are executed. So, before going to the architecture of Intel 8086, let us quickly check what are the register organization of Intel 8086 microprocessor. So, you can see that there are 14 16-bit registers. The figure which I am going to show you is the register organization of 8086. So these registers can be grouped into following categories. So you can clearly see that these four are called the general purpose registers. Whereas these two, stack pointer and base pointer, are grouped as pointers, and the SI and DI are grouped as index registers, and the other is segment register, and the below two is instruction pointer and status register. So let us start with the general purpose registers. There are four general purpose registers, namely AX, BX, CX, and DX. Each of the general purpose registers can be used either as a 16-bit register or as 2-bit register, either 16-bit or 8-bit, 8-bit. They are used to hold arithmetic and logical operands and results during microprocessor operation. The register AX, the register AX serves as accumulator, as obvious from the previous microprocessor model, and BX, CX, and DX are primarily meant to hold data, but they also serve as special purpose registers. For example, base register BX is used for memory address calculation, and CX used as counter by certain instruction, whereas DX used to hold IO address during certain IO instructions. Now come to the next group, pointers. There are two pointers, namely stack pointers SP and base pointer BP. SP points the stack top address. It contains offset address in push, pop, call, interrupt, and return instructions. Stack address is computed by adding the content of SP and SS. The BP is used for accessing stack within stack. Several data areas may exist. BP is used to hold the offset of the base of a data area in stack segment. BP is also used as a general purpose register. So next come to the group index register. Source index and destination index are the index registers. So you can see from this table source index and destination index. There are two registers in this group. They are used for memory and stack address computation. If the content of SI are added to the content of DS, that is data segment, we get the actual source address of the data. And if the content of DI destination index are added to the content of ES, that is extra segment, we get the actual destination address of the data. So now, what are the segment register group? The memory used with Intel 8086 based system is divided into four overlapping segments, that is code segment CS, data segment DS, stack segment SS, and extra segment ES. They are of size 64 KB each, and their code segment which contains the instruction codes of a program, data segment which contains variables and constants of the program, stack segment which is used to store the address and data of a subroutine, and extra segment contains the destination of some data of certain string instructions. So these four are the segment groups. Now the instruction pointer. The instruction pointer, whose short form is IP, acts as program counter. It points the next instruction to be executed within the currently executing code segment. Its content automatically incremented as the execution of a program proceeds. So the last group is the flag or status register, and we will going to discuss this flag status registers in the next class in a detailed fashion. So this is the end of today's class.